Here we go, the algebra of matrices. I really kind of think of it as the arithmetic of matrices. The goal is to add, subtract, scalar multiply, and multiply matrices. We have two kinds of multiplications, but no division. So, how do you define operations on these objects we call matrices? Well, first you have to understand that remember what a matrix is. It's a rectangular array of numbers. It has an order. Every matrix has an order, right? The number of rows by number of columns. So we have to start with a definition before we define the operations. Two matrices, A and B, are equal or equivalent, i.e. A equals B, if and only if. IFF stands for if and only if. Their corresponding entries or elements are equal. So, this is a really basic definition. If you're told that the matrix 1, 2, 3, 4, so a 2 by 2 matrix, equals the matrix with entries A, B for the first row, C, D for the second row, then you know for sure what A, B, C, and D are. A is 1, B is 2, C is 3, D is 4, right? There's a correspondence between the entries. In the last few hundred years, this notation has been invented. It's not that old. It's not like thousands of years old. And somebody had to invent, what's a way that makes sense to add matrices together? So we have three matrices here in this example. A is 1, 2, negative 3, 4. B is 0, negative 3, 2, 3. C is 0, negative 2, 5, 3, 7, negative 1. If you're inventing this, how would you add A and B together? What would be a way that makes sense? What's really the only way that makes sense? Add corresponding entries. And that's exactly what we're going to do. So it shouldn't be a big surprise. So A plus B, by the way, we use capital letters usually to represent matrices. Lowercase letters usually represent just single real numbers or a variable range of real numbers. So A plus B, now let me write this out since this is the first time we've defined it, is going to be 1 plus 0 for the upper left-hand entry, 2 plus negative 3 for the upper right-hand entry, negative 3 plus 2, lower left, and 4 plus 3, lower right. Now, would I expect you to show all that work? For this, no, just do it. You could do it in your head. So what do we get for our final matrix? Just going across 1, negative 1, negative 1, 7. Whoops. It's a bad-looking 7. Okay? So you defined it. Mathematicians aren't that crazy. They define it just the way you would expect them to. What if I asked you to find A plus C? What would you tell me if I asked you to find A plus C? So A is this matrix. C is this matrix. What would you tell me? No, you'd tell me to get lost. They're not the same order, so how do you add corresponding entries, right? So that's the only time it's okay to tell your teacher to get lost. Go blow your nose, Mr. Chamberlain. It's another way of saying get lost? I don't know. I just made that up. Okay, so what's the order of A? 2 by 2. What's the order of C? 2 by 3. So we say A plus C is undefined. I can think of a way to define it. Maybe you only add the corresponding entries in the first two columns or something. But in general, if you're not defining some new funky way to add it, we'll say that this addition is undefined since the orders or dimensions are different. Can't do it. Okay? Not too bad yet, right? And if I ask you to find 2A, what's a way that makes sense to do that? By the way, remember vectors? God, it's been a long semester. Doesn't it seem like vectors was like 6 months ago? Okay, remember vectors? Vectors are kind of like matrices. In fact, you could call them matrices, certain kinds, right? You could think of it as a row matrix, any vector, the way we've defined it in this class. So if you take 2 times A, think of how we multiplied a scale. This is called scalar multiplication. When you multiply a real number times a matrix. It was called scalar multiplication for vectors too. Remember that? And it really did mean scaling the arrow if we thought of the vector as an arrow, right? So what do you think 2a, how is that going to be defined if it's going to be consistent with our vector version of scalar multiplication? You're going to multiply 2 times what? Every entry, right? Yep. So some things we do in math make sense. So what would this be, by the way? If a is 1, 2, negative 3, 4, just double everything. 2a is, help me out, it's Friday. I can't do arithmetic. 2, oh, you're going down. Oh, a rebel. All right, I like that. 2, negative 6 going down. 4 and 8. Mathematical rebel, yeah. Okay. Now, take a look at what we're doing in part D. We're saying combine operations. Take b minus 2a. Okay. Are we going to do the subtraction first or multiply first and then subtract? Yeah, the order of operations is going to be the same for matrices as it is for real numbers. So we're going to take b minus 2a, but we have to take twice a first. Well, we already did that in part C, so we could just write it out like this. B is the matrix 0, negative 3, 2, 3. And we already know what twice a is. If we didn't know it, we'd have to compute it right now. So minus twice a is 2, going across 2, 4, negative 6, 8. And this gives us the opportunity to define subtraction of matrices, right? But subtraction is really just adding opposites. So what are we going to do here? Just subtract the entries in twice a from the entries in b, right? Yeah. So what's that going to look like? 0 minus 2. I'll go ahead and write it out since it's the first time we've looked at subtraction. What's the next one going to be if you write it out? Negative 3 minus 4. That's the upper right-hand entry once we simplify it. Then the lower left entry is, yeah, but I'm going to be a rebel and say 2 minus a negative 6. Or maybe you're the rebel for doing it all at once. I don't know. Defining mathematical rebels, I mean, come on. We're all kind of geeks, right? Us mathematicians, not you guys. 3 minus, actually, it's just 8, isn't it? 3, oh, you're, so you're not wrong. You were being a rebel. I like that. Next time I'm wrong, I'm going to say that. Yeah, I'm not wrong. I'm just rebelling. Okay. All right, and then what does that simplify to be? Going across, negative 2, negative 7, 8, negative 5. There you go. So no big deal so far, right? I mean, if I hadn't defined these things, you probably would have done the homework and figured everything out yourself, right? Just by trying what makes sense. Any questions on that? So in this one example, we defined addition, scalar multiplication, subtraction, how to combine operations.